Thank you very much, sir, for an excellent introduction. So I'll try to take it forward from here. Again, as most of you know, I represent Customized Energy Solutions and India Energy Storage Alliance. I think in the morning, Anson showed the IIT Madras Research Park covered as a incubator of dreams. So back in 2012, again, we had this dream that India would emerge as one of the biggest markets for advanced energy storage technologies. That time there was not much attention being given to this. Most of the people were saying that it would be 2020 before developed countries will adopt it, and it will be another 10 or 15 years before India will start adopting these technologies. But we firmly believed that actually India can leapfrog in this area. And that's where we started with 5 member companies as India Energy Storage Alliance. And now it has become one of the stronger policy advocacy platforms and an industry networking platform, as Dr. Kalai Selvi mentioned in the introduction, with more than 160 members. So when we look at energy storage, it is not only about batteries. Again, sir covered a lot about battery technologies, and I'll also mention a little bit. But energy storage, we feel that in terms of the policy and in terms of the opportunities which are there, we need to work on it as a cohesive technology spectrum, where many of the policy changes which will happen will enable not just the batteries, but possibly other gravity-based storage technologies, mechanical storage technologies, chemical technologies, because it is not a fight between different storage technologies within the with each other, but all these technologies together can help accelerate the transition for the net zero. Based on different applications, again, there is no single technology which is a perfect for all applications. So typically when we look at evaluating different technologies, there are 7, 8 or possibly 10 plus parameters. Many times in India, we focus on cost. So you won't find a single slide talking about cost, because most of the time we spend time talking about it. But especially with lithium-ion batteries, in fact, Milind asked the question about is there anything else which has matched the kind of learning curve which solar demonstrated. So in fact, lithium-ion batteries have demonstrated similar cost curve in a faster trajectory, where unlike solar from 75 to 2021, lithium-ion batteries demonstrated similar 90% or 5% cost reduction curve between 1993 to 2020. So there are a lot of things happening on the cost side, but actually what is exciting is there are a lot of improvements happening on other parameters such as energy density, power density, round-trip efficiency, safety, and other aspects, which is going to make many more applications viable for energy storage technologies. So here is just, we are plotting different ways of looking at energy density. So one is looking at it from the volumetric perspective, another way of looking at it based on the weight. And you can see that there is significant improvement which has happened across multiple technologies. On the left-hand side chart, you are seeing the current dominant technology with LFP, NMC, NCA chemistries. And then on the right-hand side, you are seeing some of the new technologies which are right now still in early commercialization, including lithium-sulfur, metal air batteries, and how those are going to improve. We plotted it on a 2 separate chart because otherwise the y-axis will suppress the improvement which has happened on the current technologies. And again, so we do feel that it's not that we are looking for one perfect chemistry. There are different applications, like automotive applications may prefer energy density and may go for NMC or similar chemistries. At the same time, there are reasons such as the temperature tolerance or safety, where in India particularly, there is also stronger interest for LFP or LTO batteries. I'm sure Akshay may talk about it in the next panel. And one of the key enabling factors for all this is the policy transition. And this is a journey which takes much longer. And many times I think industry wants to just wait for a perfect policy to appear, but the policies don't evolve overnight. I think Professor Jhunjhunwala spent a lot of time where he actually dedicated a couple of years moving to Delhi, working with the ministries, educating many of the bureaucrats. Similarly, as IESA, we have been working through almost with 8 different ministries over last 10 plus years in try to make sure that various policies which are taking place, they do account for the technological advances which are taking place, and we don't end up making technology dependent policies which may end up actually creating barriers pioneers for new technologies which are going to emerge in the coming decade. So in general, as an India Energy Storage Alliance, we have tried to promote for policies which are technology agnostic, which may create enabling environment for current technologies, but at the same time, they should not create a barrier for some of the new technologies or other disruptors which are coming to the table. In terms of the market numbers, we again release these numbers every year. So the current projection says by 2030, as a cumulative market for this decade, we expect the stationary storage market to be more than 400 gigawatt hour in a base case scenario, of which almost 70% of the market we project as a behind the meter market. Many times we focus on just this large grid scale project or government tenders as a way for looking at how the market is developing, and people feel that in India market is not moving forward as fast. But actually, if you see what Reliance Jio has done with telecom towers by switching completely to lithium-ion batteries and other thing, India has actually emerged as one of the bigger markets, and there are companies like Exicom which has deployed more lithium-ion batteries in India for these distributed applications than some of the biggest companies in the world as a ESS companies have done in last 15 years around the globe. But again, stationary market is not a grid side market, cannot be ignored. So we have been working very closely with Ministry of Power and Ministry of New and Renewable Energy, where we have recommended to have a target for at least 160 gigawatt hour, similar to meet the ambitious 500 gigawatt renewable energy target, what Prime Minister has already accepted. In principle, this is accepted by Ministry of Power, and currently there's a discussion going on with PMO office to see if this can be launched soon. E-mobility is going to emerge much faster. Dr. Gopalan talked about some of the CAGR numbers, where you can see that certain markets like consumer electronics, which was dominant market 2 years back for demand for lithium-ion batteries, may not actually feature when you look at into 2030 numbers as a more than 5% of the total market, because that market is growing at maybe 5%, 6% year on year, whereas the e-mobility market may grow at 30% or even 50% year on year. And as a cumulative, if you see that the overall demand will get dominated by the requirement for e-mobility, and we do project that just the annual market in 2030 for e-mobility would be anywhere from 80 gigawatt hour to almost 140 gigawatt hour, depending on the different scenarios of how e-mobility picks up in India. So looking at this in 2016, we started focusing on the manufacturing policies. So you are seeing on the left-hand side the first report what we submitted to Niti Aayog in April 2016. And since then, we have been working with industry, with partners like IEMA, ARCI, CMET, and others for doing capacity building for it. We were glad that in 2018, actually, Prime Minister's office also took note of this effort and jointly invited industry for looking into both solar and energy storage manufacturing, and that led to creation of the production link incentive scheme in 2020. Although with COVID there was a year and a half delay, but we are very glad that from the original vision what we set out for 20 gigawatt hour manufacturing by 2020, although we are late, now the vision is much bigger, and already there is a 50 gigawatt hour production link incentive program. 4 companies have been selected. There is an additional 25 gigawatt hour of production link incentive program for stationary storage technologies expected by Ministry of Power before end of the year, and there is an additional 5 gigawatt hour niche ACC PLI is also going to get released hopefully before end of this month. And most of these gigafactories will get started commercial operations sometime in 2024. So this was a vision what we released last year on World Energy Storage Day on 22nd September, where we said that 50 gigawatt hour is a good starting point, but we cannot be happy with that. We need to look at going from achieving 50 gigawatt hour by 2027 to at least doubling it to 100 gigawatt hour by 2030 and 500 gigawatt hour by 2035. When we released this, many people laughed at us because this was released before the actually PLI was introduced. So many people said we are not even sure if in India there is a 50 gigawatt hour manufacturing manufacturing going to take place, and you are talking about 100 and 500 gigawatt hour number. But I'm happy to say that in last 6 months, actually, the kind of response which have been received by the industry, now people are saying that the 100 gigawatt hour manufacturing vision, what we set up for 2030, will get met in 2028 or 29 at max. So to support this, now we need to start looking into a complete holistic manufacturing ecosystem, because you cannot just manufacture, and it was highlighted by Milind and Sujoy in the morning session about solar, where with solar, I think world has made the mistake where we are quite significantly dependent on one single country for not just the manufacturing, but also almost entire supply chain, which we are now trying to break through. So with storage, we cannot repeat the same mistake. And this is something which is not just India, but Europe as well as US is also trying to break through the Chinese monopoly, because people have just realized that because of COVID, you cannot have dependence on any single country. It is not about just China, but people are looking for multiple sourcing options. And that's where we believe that India can actually play a much bigger role, that developing the ecosystem for not just supporting Indian gigafactories, but actually vying for a global market. Because while we are looking at having 500 gigawatt hour manufacturing in 2035 as a vision, the global manufacturing capacity will be at least 5,000 gigawatt hour, if not 10,000 gigawatt hour. So if we can actually develop the manufacturing ecosystem of the supply chain for the gigafactories, we don't need to be looking at just the Indian 50, 100, 500 gigawatt hour manufacturing. The global market is 100 times bigger than that. And that's where I think we need to vie for becoming at least a 10%, 25% kind of a player in that global marketplace. The good part is there are many investments have already started pouring in. So these are just some of the public announcements which have already happened. Some of those are for battery pack, many of those are for cell level. But now going forward, we see a lot more investments actually coming into different states for specific anode manufacturing, cathode manufacturing, electrolyte manufacturing, separator manufacturing. And there is going to be uncertainty. So I think as an industry and academia, researchers, we need to start living with the uncertainty, because there is not going to be a perfect chemistry which everyone is going to adopt. So there is, within lithium-ion batteries, there are almost 7-8 different types of cathode chemistries. There is a innovation happening on the anode side where we'll move away from maybe graphite with graphite and silicon anode, or moving towards lithium anode. We may look at other technologies for longer duration storage, including flow batteries, metal air batteries, and many other chemistries may come up for some of the niche markets such as drones, where the weight is most important. The 500 watt hour per kg number which was mentioned, again, that may be a luxury for electric vehicle and good to have, but that is absolutely essential for having a drone which has a sufficient carrying capacity and distance capacity. So I think different markets may pick up different technologies, and this is sort of a general expectation of how there will be market which will exist for number of different technologies. And if you sort of map it with the growth of the market, because world started with hit the first gigawatt hour of global manufacturing was hit maybe somewhere around 2000. It took the world almost 20 years to reach to 1000 gigawatt hour. Now in next 5 years, we are going to install at least 2000 gigawatt hour of additional manufacturing. So although the numbers may seem that some of these technologies have very small percentage, considering the global market, many of these individual technologies may have few hundred gigawatt hour kind of a market potential. So there is a tremendous opportunity for entrepreneurs to get involved in this area. Dr. Gopalan showed this chart in a text side, but this is just a visually to show how you go from mining to material processing to battery material processing and then cell production and other. And there are going to be lots of opportunities available in the complete upstream and midstream supply chain. The current ACC PLI focuses mainly on just cell production, but there are incentives included in form of ensuring that at least 60% domestic value addition needs to happen, which is creating a reason for people to invest. But again, we are trying to right now work with various members of IESA in coming up with a policy ask for both state as well as central government on how we can actually systematically process, create this processing industry. One of the areas is that I feel that we should sort of start moving away from these imaginary or arbitrary cost targets of $1 per kg for natural gas or certain price point for battery, because it was earlier $500 per kilowatt hour, then it became 200, then it became 100. Now people are talking about $50 per kilowatt hour. Soon people will start talking about $10 per kilowatt hour. There are actually a lot more other aspects which we need to start focusing on. For example, when you look at the complete manufacturing supply chain, I think right now China gets villainized quite a lot, but I think all of us should owe a huge debt for the environmental cost which China is bearing for creating all this chemical processing. Now, we don't need to compete with China on getting a share of that part. We can look at actually alternate manufacturing processes which are environmentally much more sustainable and cleaner, and there are already policies emerging in Europe, in US for supporting such manufacturing processes. So again, we don't need to look at just what China is doing right now. If we can add certain different attributes, if we can eliminate certain other costs in terms of recycling or wastage and other things, then there could be again a lot of opportunities for innovation. So it is not just incremental innovation, but we can have a transformative innovation when we look at the complete supply chain. And here we have an example with Lucas TVS and TVS Indion, where they have now partnered with 24M from US for looking into a semi-solid manufacturing process, which is a complete game changer in the lithium-ion battery manufacturing, because almost 99% of the manufacturing globally, which is happening right now, similar to what Dr. Milind showed for solar, has built on sort of a magnetic coating, which was done for audio tapes or video tapes earlier by Sony. And that process was sort of incrementally adopted for doing cell manufacturing. And you saw the video by Dr. Gopalan in terms of how the process works. Now, with 24M new innovative manufacturing process, there is a significant reduction in the steps required as well as various wastage which is happening. So those type of innovations are also possible, which could create a significant disruption in the market. And last thing I would say that I think Milinji also mentioned this in his talk, that it is not only about shortage of capital or looking for technology, but one of the biggest constraints is going to be on the skilled manpower for the Gigafactory. And that's where we are super excited with our partnership with Professor Junjunwala and IIT Madras Research Park, because this is a place where many of these next generation entrepreneurs are coming in, but it is not only about entrepreneurship. We need intrapreneurs, we need skilled engineers and manpower to get integrated with these things. And there are many more. This is just I have listed like 4 key areas in terms of the Gigafactory manufacturing where we need skilled manpower, but there are probably 50 different areas where we need different interdisciplinary skills to be used for going to the next level of manufacturing. So we are working with IIT Madras Research Park as well as other partners, both in India as well as US, for driving these collaborations. We are also happy that agencies like UNIDO has partnered with us for supporting funding for beta deployment of innovative technologies, where there is around $1.5 million allocated for specifically energy storage deployments by UNIDO, and many more such activities are happening. So again, the skill development is going to be very critical, and we are looking forward to having more partners. If there are any academic institutions who would like to join hands with IESA Academy for partnerships, please do let us know. We will be happy to work with you for making sure, because we cannot keep on incrementally growing the people we are reaching out to. We need an exponential growth also in terms of how we can reach out to a large number of people for training. And last thing I would just mention is that if only risk which is there for this rapid growth is safety. We cannot just focus on cost and compromise on safety while looking at this growth. If we do that, that is going to be disastrous. Already we started seeing some of these things happening with the two-wheeler markets, and unfortunately some people have lost life, which we could have easily avoided. Part of it is just consumer awareness, where people are keeping the batteries for charging in their bedroom, or there are issues related to the power quality which may be causing some of the challenges. So a lot of these things can be addressed, and we need to make sure that every one of us who is involved in this ecosystem takes safety not as an optional, not as a luxury, but as an essential thing, because that's the only thing which can derail the growth of this sector. We do see that the renewable growth is going to be unstoppable. The cost parity has been reached, but now we need to realize that the cost parity cannot be just in terms of the dollar per kilowatt hour on energy, because the time value of energy also is going to be important. And that's where renewable plus storage is the combination which is going to lead the way. Many times people ask us question that, oh, is green hydrogen a competition for batteries? My answer is no. Green hydrogen, for reaching its potential, you are not going to run these electrolyzers for 20%, 30% of the time just using solar or wind energy. You are going to require at least 70%, 80% utilization factor for the electrolyzers. And that means actually the growth of the green hydrogen will create more opportunities for batteries and other industries. And together, stationary storage and green hydrogen and e-mobility will enable the vision and dream what Professor Jhunjhunwala talked in the morning, because this is not a luxury. The cost of the climate change is getting borne by the poor people most. So this is not something where we should just wait for these technologies to mature. We need to get started very fast. And I think all of us together, we can do it. Thank you.